Off you go.
Welcome everyone. This is the Lake session at IETF 121 in Dublin. My name is Malisha Vucinic and my co-chair is Stephen Farrell.
Hi.
So we are starting. So as for any IETF meeting, the note well applies. Anything that you say or write in the chat is considered a contribution to the IETF standards process. If you are aware of any patents, you are kindly requested to disclose those. Please keep it professional. We had no issues in this working group previously with any unprofessional behavior, but let's keep this in mind. Please, when coming into this room, you should have scanned the QR code to sign into the Meet Echo client. So if you haven't done so, please do so. Please do. So this is obligatory for both on-site and remote attendees. So here are some resources for the today's session: the link to the agenda, the Meet Echo link, and the link to the minutes. I believe we have 3 note takers, so I would very much like to thank Giovanni, Christian, and Marco for taking notes. So since each one of you will be presenting, I guess you can coordinate among you to cover for each other when you're presenting. So in terms of status of this working group, we have 2 working group items that will be discussed today. The implementation considerations draft that is led by Marco is its second version. It will be discussed today. We have the Lake Odds draft in its 03 version. Also, that is editor is Giovanni Fedraszewski. And he will be discussing it today. But we also have 5 individual submissions, and we will be seeing all of these presentations today of these of these drafts that have been around for a while, but also there are some 00 submissions. So this is what the proposed agenda looks for the day. So we will start with the working group items, Lake Odds and Lake implementation considerations by Joanna and Marco, 15 and 10 minutes respectively, then followed by non-working group items, individual submissions, draft on remote attestation, on Greece, on pre-shared key authentication with ad hoc, application profiles, and then the latest 00 submission on trust anchor hints by Marek. So we are currently missing the slides by Marek, and I have been informed that he will be joining 30 minutes into the meeting remotely. So I guess he will have to share his slides, share his screen when the time comes. But I will be asking Marek to upload the slides anyways into the data tracker. So with that said, does anyone want to bash this agenda?
Nope. Good.
It seems all good. So I propose we get started then. So the first item on the agenda is the draft IETF Lake Odds by Giovanni Fedraszewski. So Giovanni, you have 15 minutes.
I think you need to put the slides up first.
Yeah.
Does this work? No. Try it and see.
No,
Try it and see.
no, it doesn't because I'm presenting from again.
Okay, so hello, my name is Giovanni, and I am working on lightweight authorization using ad hoc. And next slide, please. So today I will cover draft updates, including, we gave it a name, some new sections, new appendix, and I'm sorry, this is not the last version.
It's not the yeah. That's
sorry. Yeah, I sent a version just.
That's the one that was picked up by Miteco. Let me try to refresh. So how can I refresh it? No.
If it's not possible, it's fine. I can. It's mostly consideration on next steps.
Go with the first. Go with what we have.
Yeah.
Okay, so apart from what we see here on draft updates, I will also discuss some next steps. And this was like a discussion just before here, so we have been talking about this. And then I will also show some performance evaluations of the protocol in its current states. Next slide, please. So beginning with the updates. Next slide. So in IETF 120, we discussed it. So here it was the state of the protocol. So just a recap for those that are new. So we have a device, a domain that wants to join a domain through a domain authenticator, and it's aided by an enrollment server. And between you, the device, and V, the domain authenticator, ad hoc is running. And every time I was presenting this, I was discussing that sometimes we call this alt or zero touch. So next slide, please. So now it has a name, and it's called ELA, ELA. So ad hoc with lightweight authorization. Easy. So next slide, please. Okay, so with the new things. So I added a new appendix as a result of discussions about if we should use ELA using the ad hoc reverse flow. So we had some discussions from the IETF community and working group members. So next slide, please. So as a result, I added two possible options for the ad hoc reverse flow. In one of them, you or the device is the initiator. So it receives a co-op request and then responds with message one. And the other case, you is the responder, and then it sends a co-op request and then receives a message one. And they have different trade-offs in terms of identity protection. But the reason why we may do it differently is because in some network technologies, the device initiates or then the network initiates the conversation. And yeah, that's it. So next slide, please. So now talking about optimization strategies, here we are discussing a problem that was also discussed in the IETF 120, which means if a device U tries to join a network, but it detects many VIS, many gateways in its radio range, maybe it takes a lot of time until it finds the appropriate gateway to join. So how to solve that? Next slide, please. So after lots of discussions, this works? Cool. So after lots of discussions, we isolated these two strategies. So one of them is you broadcast message one. The good thing about this is that there's like minimal changes to the protocol. So actually, the only change is in the lower layer, how the network will send message one, and then a few considerations on how message two should be considered. And we also consider that errors should be suppressed in this case, because if V encounters an error, it will not send back a response, because generally we don't want to send errors as response to broadcast or multicast messages. We had a deep discussion about this on the Saturday during the hackathon. And the other strategy is advertisement. So meaning V can send a struct, we are calling it a V info. So some information about V to any U that is out there to receive, so that you can have this information and then decide to which V to try. So this can help you spend less resources trying and retrying to join until it finds a suitable V. And actually, there are many ways to implement this. They may depend on if we are using ad hoc forward or message flow, if the connection is initiated by device or network, or if it's a co-op client or server. So the number of possibilities explode. So after lots of discussions, I isolated basically three example strategies that have been included in the draft. And so basically, one of them is include vInfo in network beacons. And we know that this works with a few technologies, for example, Bluetooth Low Energy and IEEE 822.15.4 in beaconed mode. And it's this case. And one trade-off of this approach is that it requires that the beacon can be extensible. The other option is including vInfo in EAD1, and this requires using the ad hoc reverse flow. So it's good that we now have it defined on how to use it on the protocol. And the final example strategy is that vInfo can be included in the co-op multicast packet that is periodically sent by V through the network. So device can receive this packet and then use V info to decide. So basically, those are three ways that V info can be conveyed from V to U. And these right now are framed as advertisement, as example strategies for advertisement, but they may evolve into mini profiles for particular technologies that may be more concrete. Okay, so before going into the evaluation, we just had a discussion about next steps, and we are interested in a few things. One of them is because we are now defining all these possibilities of what can happen, but essentially this is all into the use case that Ella is used for onboarding or enrollment of new devices. But actually Ella is a doc with lightweight authorization. So the main idea is authorization. So we want to separate and have it in an interoperable way, the core of the protocol, that is authorization, and then out of that we define how it can be used for enrollment. That is one thing, and another thing is fixing the rest of the protocol in terms of which fields are used when the reverse flow is applied. So that includes some of the draft updates that we plan to do for the next version. And here's some evaluation that we performed. So basically, we implemented Ella in the Lakers implementation in Rust that we have, and ran them on 2 different platforms and compared with other protocols. So one of the platforms is the AIoT Play. It runs on an NRF 52833 and uses the Smart Mesh IP network, which is a duty-cycled low power network with support for multi-hop and creating messages. Sorry, not messages, mesh networks. And we do a comparison with IP ad hoc in terms of message sizes and handshake duration. We also run Ella on dotbots, which are those small robots that are used for education and research purposes. And we evaluate several metrics. So beginning with the comparison with IP ad hoc. So here is the setup. So basically, our V is the IoT playboard. Our U, our device, is the AIoT playboard. Our V is server, a handler, a Python script, and then we have the enrollment server. So this translates to Ella, U, V, and W. And then for IP ad hoc, we have the peer is the device, and the authenticator is our Python script. We don't need the server in the IP case. So here's some results. So first, here on your right side, we have message size. So as you can see, this is Ella, and this is IP ad hoc. And actually, the size difference is not so big. So it's about 10% here. What we can see is that IP sends way more messages in terms of number, but normally these messages are very small. So, but what happens if we try to run those messages on a duty cycle network? So what happens is that there are more slots where the network is waiting to be able to send. So when there are more, because of the chatty nature of IP ad hoc, it takes about double the time. So in here for Ella, it's about 8 seconds on average. And then for IP ad hoc, it took about 15 seconds. So that was an interesting find on this comparison. Next, Ella on dotbots. So we have our device is the dotbot, we have a controller, and we have an enrollment server. And this is a network that is always on, is our own implementation on top of raw BLE network. So first on message sizes, so that we can see the overhead of the EAD items on top of the message one, ad hoc message one. So here it's about basically doubles the message. Message 2 is just a small addition. It's about 12 bytes. And it's just a voucher, which is basically a ciphertext, which may be empty with authentication tag. And then message 3, there is no addition. An important caveat here is that cred v is sent by value in message 2, because if you want the zero-touch capability of when using the enrollment use case, then we have to send credit by value, because otherwise you cannot know who is the gateway. It cannot be pre-configured with all the possible gateways. So we have to send it by value. We also evaluated the overhead in terms of flash and RAM usage. So it's about less than 2K overhead in flash and less than 1K overhead in RAM, where the maximum here for flash is 16 kilobytes and RAM is 4 kilobytes. So it's interesting to see that the approach to reuse ad hoc, not only for the cryptographic primitives, but also for the encoding, it's very efficient in terms also of the implementation. And here we have a chart showing the energy usage. So this y-axis is current consumption. Here we have time. The blue line is the current, and the red line is the accumulated charge over time. So basically, here's the device is idle, just listening. Remember, this is Bluetooth Low Energy, so in our implementation, it's always listening. So it's idle, consuming some power. And then the ephemeral key derivation begins. Then it's preparation of EAD1. Then it's the time the message is sent. It's very fast because the message is small and we have 1 megabits per second. And then a time for the server to process the EAD, generate the voucher, and send it back. Then message 2 is parsed, decrypted. EAD item 2 is processed, which is very fast. It's just basically verifying the MAC. And then message 2 is verified. So this EAD item is verified before. If we look into the implementation considerations, it's like a pre-processing EAD item. Yeah, and then important here to note is that crypto is done in software here. So that's why we have a long time for some elliptic curve operations, especially. And that's it for my part. Thank you. Questions?
Do we have any questions for Giovanni? So could you just summarize the next steps? Oh, so we have Rafa in the queue. Rafa?
Hello, can you hear me?
Yes, we hear you well.
Okay, Ivan, just very interesting presentation. I was kind of, maybe I missed some version of this, but about your comparison with IP ad hoc, I was trying to understand what is the purpose of that. Because, I mean, how is that the reference here?
Okay. So we simply want to understand the so in the context of our work, we are trying to understand how the protocol compare with other similar solutions that exist. So it may make sense to use one or another based on different requirements. It's just that.
Okay, yeah, because you know, it's when you think about IP, I was thinking .1x or whatever network access, you know, technology, but that uses the IP actually, because in some places you cannot use anything than IP, for example. I was thinking that the only way to run that authentication is using IP. So. And IP is authentication, but not authorization unless you include the AAA server in the backend. So, but I understand your comment. So, thank you.
Yep, thank you. I totally understand. And yeah, there are cases that ELA cannot be used because IPs are already deployed. So yeah, it's I think both cases are used. Mm-hmm.
Okay, so we have. Yes, Yogesh?
So for what type of key support you have for crypto and stuff for signing?
Okay, so we basically can use the cipher suites defined in the ad hoc RFC. So that includes elliptic curves. Yeah.
And the format, is it, presumably you're not supporting X.509 because it's on a constrained node? So
It can be supported, but we also supported more constrained, more efficient credentials, such as CBOR claim sets, like raw public keys.
okay, I think I will ask the attestation question later. Thank you.
Thank you.
Thank you. With that, we close the. Is there any other questions? No. I see nobody in the room remotely. No. Okay. So one last question.
Yeah, Renzo Navas. Thank you, Giovanni. Quick question. I would like to the second test. Why you didn't include also the comparison with other alternative? Would have been interesting to see, because the first result you present was very interesting to see that you use less, half the time almost.
Mhm.
So why for the second experiment you didn't include the alternative, or you plan doing on future?
Okay.
Or you-
So well, for the second experiment, our expectation, essentially, we have to deploy Ella in the dotbots in a project that we are doing. So we just measured what we had. Yeah. Mhm.
Thank you. With that, we close the queue. So thank you, Giovanni, for your presentation, and
Thank
we
you.
invite Marco for the next item on the agenda. And this is implementation considerations for ad hoc. Marco, you can use the presenter.
Thanks. Hi, everyone. This is Marco, an update on the implementation consideration draft. Yeah, as a recap of the scope, the ad hoc RFC rightly focused on the ad hoc protocol in itself. A number of things were just real implementation specific, were deemed to be better elaborated in a separate document, which is this document. And so far, based mostly on my experience and a few input, we are covering a number of aspects, mostly on what to do when sessions and key materials become invalid and have to be purged, and you have an increasingly complex set of situations depending on using ad hoc standalone or combined with some form of authentication and access control, or helping side key update protocols. We cover also a number of trust models for the strictness in learning on the fly while running ad hoc new authentication credentials of other peers. And the most complex part, the branching out of incoming message processing, especially message 2 and 3, for the sake of after decryption, especially evaluating authentication credentials and EAD items conveyed therein for embedded applications. And we have recently also added some more information on considerations to take into account for when co-op specifically and blockwise are used while running ad hoc. We'll see in the next slides. I've also started to cover a bit more in detail recently some two particular use cases or cases in point that are applications that can be sort of embedded in ad hoc. And one is an authentication and authorization profile for the ACE framework. That's a nice document. And the other one is the document that Giovanni just presented. Okay, going through the update for this version, I tried to align a bit better the content that was already started to be included in this document with respect to how ad hoc is specifically used in the profile of ACE that uses ad hoc, so the ad hoc _ profile of ACE, just to generalize that the so-called outcred-C as the authentication credential of the ACE client in that profile can actually be CredI or CredR in ad hoc, depending on the particular message flow that is used. And also on updates recently made to that ACE document related to the ways for uploading the access token with the access rights specified there to the ACE resource servers. Simplifying here and considering only the first upload of a first token haver, so excluding update of access rights, we have nailed down the options for the ACE client to upload the token to the resource server by itself, only in one way, including it in an EAD item. There is a totally alternative way relying on a totally alternative workflow of ACE defined in a separate profile independent document. And that's also now mentioned in the version of this document with discussion around that. And I've also tried to clarify how, again, in that profile, the resource server builds specific associations when receiving and accepting the token between the token itself and a pair ad hoc session just run and the OSCORE context derived from it. And as long as the token is still valid and the client decides to run ad hoc again, there's going to be a new ad hoc session with the corresponding derived security context. And this new pair becomes the new pair bound to the same still valid access token. All right, on the trust models, there was a lot of discussion even before adoption about this, and we still have only two models. It used to be three. I'd like to keep them two, not three again. They still mean the same thing. Basically, learning is very generous. A peer running ad hoc is just happy to learn any new credential of another peer received while running ad hoc, as long as the credential is valid, of course. Whereas no learning is pretty strict, it's not fine to learn anything. Doesn't matter if it's valid. And I realized that if keeping no learning so strict verbatim, we were basically preventing the functioning of, well, the two application cases I mentioned before, where they are such that peer is supposed really to learn on the fly some new credential. So rather than opening for a third policy again as a sort of hybrid, I prefer to try considering, in case one really wants to go for the no learning policy for a particular ad hoc resource, to open for possible exceptions that have to be very situation specific, and they have, of course, to be still double checked and decided to be good to pursue for that particular ad hoc session. And again, we have two main cases in point, the ad hoc and OSCORE profile of ACE and ELA or ELA. And it was quite simple to actually update the message processing and diagrams around that, considering that update. And building on that, I tried to give a concrete example with this in mind too. And on the first case in point, the ad hoc and OSCORE profile of ACE, I have quite good text already, I think, in section 3.1. Well, it's more a placeholder for Lake OZ, but essentially what is supporting and justifying the exception for the no learning policy in that case is the expectation of a particular message queue with a particular EAD2 item, including the voucher that really supports the learning of a new authentication credential, building on the vouching provided by the W node. And a final remark, there's a section for one. After submission, I realized, thanks to very good discussion with Joran and Ricard, especially, that text is basically moot. I over-worried about the need to give particular guidance on very particular processing. In that corner case, there's apparently no need to say anything special, and just following the policies as they are documented in the previous pages, things should fall correctly, and you should end up with the conclusion that you expect to have when enforcing those policies. So I'll remove that section. Don't bother reading it. Okay, and finally, in the previous version already, we added a new section providing guidelines for the particular case when ad hoc is run over co-op and blockwise transfer for co-op are used. That original content used to be in a version of a core document, which is now in Auth 48, and then it was eventually removed after having become an appendix, because it was something more generic than that and implementation specific, and eventually it landed up in this document where I think it was good to have. So I've revisited it now, and I realized that it really had in mind the context of that core document a bit too much. Some lines were even wrongly given the impression that blockwise here could work, could be limited only for the particular case of the optimized ad hoc plus OSCORE request, but that's totally not the case. So I try to rephrase a few things to not give that wrong impression anymore. In the process, I prefer to change the name of some identifiers, also more aligned with the terminology of blockwise transfer, and like clarify the wrong sentence that we had, that we're given the pressure that in the particular case where you use the ad hoc plus OSCORE combined request, the fragmentation from blockwise is applied to such a request, but that's not the case. If you take that path, it's actually applied to the plain application data that then end up protected with OSCORE, and in turn, as the second part of the combined request. So the current formulation should be correct. Okay. Right. This is more for information, and to not forget, Giovanna sent out a mail in August to the mailing list related to the work on OutZ. Probably the details of that mail are obsoleted now, or considering that the discussion, the update, it was mostly to suggest mentioning in this implementation consideration document about the importance for an ad hoc peer when running ad hoc to stick to the step of the protocol that it has reached, and especially not process a message twice. Yeah, totally agree, but that seems already very clearly stated in the protocol specification in the ad hoc RFC. So I'd prefer to not repeat that here with the risk of confusing restatement. I think what the RFC says is pretty clear already about that. All right, and as next steps, I'll come back to the no learning policy thing, especially removing that mood section that I mentioned before, and I want to clarify a bit more around that on what is currently just a to-do placeholder for the LakeOutZ case, and there's more to do around that area for the sake of comparison and consistency checks of authentication credentials if they appear by value or by reference in IDCredX, as it is unavoidable in message 2 and 3, but at the same time, also depending on these particular examples in some EAD item. And at least as a direction, we have placeholders already. There's more to do on security consideration, and I still like to have some appendix providing example credentials, especially certificates to take and use for testing. I would really appreciate input from other implementers, not necessarily of ad hoc in itself, but also outside and array, especially in terms of lesson learned. And that should be all from my side. Thank you.
Thank you, Marco. Do we have any questions? Okay, I see no one in the queue, so I guess we can move on with the next agenda item. Thank you, Marco. So the next item on the agenda is remote attestation, presented by Yushwan. Okay. So you have 15 minutes, Yushwan.
Yep. Okay, so hi, I'm Yuxuan, and this presentation is about thank you. It's about the updates of the remote attestation over ad hoc, which is the draft to specify how to perform a remote attestation within ad hoc by using the EAD field. So first we restructure the draft to make it more clear to describe the different possibilities for performing attestation in ad hoc, and also it's based on Yoran's comments in like working groups. We have a new section called remote attestation in ad hoc, where we have defined 3 dimensions for the remote attestation process. We have first the target, which indicates that either the attestation is an IoT device doing attestation or a network service performing the attestation, and with the acronym of IoT and NET respectively. So then we support 2 models that following the REST architecture. So the attestation could be either performed in background check model or the passport model. And the third one is the message flow, where we can perform the attestation in either ad hoc forward message flow or the ad hoc reverse message flow. So actually, each combination of the items from these 3 dimensions can be a way to perform the attestation in ad hoc. So we here have a new section called instantiation of remote attestation protocol to describe the different possibilities to perform the attestation. And right now we have 2 most relevant cases listed. So the first one is that an IoT device performs the attestation in background check model through ad hoc forward message flow. And the second case is that the network server performs the attestation in passport model through ad hoc forward message flow. So then we also define 2 new EAD items to trigger remote attestation if it is needed. So we have first the trigger BG, which is to indicate the receiver to start a remote attestation in background check model. and it is a EAD label with empty EAD value. And we have another trigger PP to indicate the receiver to start a remote attestation in passport model, and also with a different EAD label with empty EAD value. So with this new EAD item, we have a new instantiation of remote attestation for network service performing the attestation in passport model through forward message flow. So as you can see right now, the EAD1 is trigger PP, which the device triggers the network server to start a remote attestation in passport model. And the following is the same as what we defined before in the draft, that the network server will start the remote attestation by sending a result proposal, which contains like a list of verifier identities that it can get the attestation result from. And then the IoT device will select a trusted verifier identity to generate a result request. And here we have the dashed line between the network server and the verifier, because we think that the way the attester to obtain the attestation result could be either a real-time connection that is freshness is guaranteed by a nonce, or it could be a pre-stored attestation result in the attester with a timestamp that indicates the expiry time. And then the attester will carry the result in EAD4, like we will need a force ad hoc message. And then we update our mutual attestation based on what we have, based on the new instantiation. So the updates is that right now in EAD1, we have two EAD items, which is the first one, attestation proposal, that is for the IoT device starts the attestation in background check model. And we have the second EAD item that is trigger PP to let the device signals to the network service to start the remote attestation in passport model. And the other, like the following messages are the same as we defined before, so I will not repeat here. Okay, and then we also update the example in Appendix C. So before we are showing the example in like the attestation token by PSA, but now we update it by a more lightweight version. So right now because we define the evidence is an attestation token. So right now our evidence is an attestation token that with the measurements claims formatted in COSWID. So right now here's the example like how it could be. And then also we have a full implementation of one case that is defined in our draft, which is the IoT device performing the attestation in background check model through ad hoc forward message flow. And here we have the attester, which is a macro robot running on NRI 5340 at 64 megahertz. And we have the relying party, which is a computer software that handles the processing tasks. And then we have the verifier that is a trusted web server. And then the detailed messages is the same as what we defined in the draft. So in ad hoc message 1, we have the EAD1 field as attestation proposal, where it has a list of evidence tabs supported by the attester. And the update here is that now between the relying party and the verifier, we carry the attestation proposal together with the connection identifier CR. So then when the verifier receives the attestation proposal and the CR, it will generate the nonce and associate the nonce with the connection identifier. So in this case, we can support multiple attestation procedures at the same time, because the verifier now has a list of the different nonce generated with different connection identifier for the different ad hoc session. So then based on this impulse by the verifier, the relying party will generate the attestation request and send back to the attester. And the attester will generate the evidence, which is the attestation token, and send it to the relying party. And again, the relying party will send this evidence together with the connection identifier to the verifier. And then the verifier will generate the attestation result and give it back to the relying party. And also we have the evaluation. We have did also the measurements of the remote attestation over ad hoc. So firstly, we have the memory footprint where we measure the flash and RAM memory usage. So as you can see here, the flash memory for only ad hoc is about 15K, and we have like about like 1K more than the results that is provided by Java, because here we need to enlarge the buffer size for carrying the evidence in EAD3, and this buffer size also apply to like the message size, the messages and the EAD fields. And the attestation is about like 1K bytes for flash, and for the RAM it's the same, like we have like 5K bytes for only ad hoc, also like 1K bytes, like more than the more than Geo1's result, because we have the initialization at the beginning where we should initialize like the messages 1.3 and EAD 1.3. And then the attestation in RAM is also like about 1K bytes. And for the ad hoc message size, here we transport the credential by reference instead of by value. So in message one, we have about like 38 bytes for ad hoc only message, and like 4 bytes for attestation, because here the EAD1 is only like a list contains one integer. And then for the message two is about like 45 bytes for ad hoc only, and like 15 bytes of for EAD, because we have both the evidence type and the nonce. And for message three is like 21 bytes for ad hoc, and for EAD3 we have about 230 bytes. Okay, so then we also have the current consumption benchmark, and our crypto backend is done in software. So the current in average is about 60 millions, and we can see that here the most time-consuming operation is for preparing EAD3, and for both preparing EAD1 and process EAD2 is quite time efficient. And also for preparing EAD3, like the time is mostly due to the cryptographic operations like the hashing and the signing operations. Okay, so then okay, it's not working, I think.
Oh, sorry. There.
Okay, okay. So then for the conclusion, so we restructure the draft. We define 2 new EAD items, and we have the full implementation and measurements of IoT device attestation in background check model. So for the next step, as we have mentioned in our interim meeting, that this draft could be like a call for adoption. So maybe this time I would like to require for a call for adoption. And also we are working on right now to implement the mutual attestation. Okay. So that's it. Thank you.
Thank you, Sean. So there is, okay, so we have some people in the queue. So Joanna, Osama, and then Wei. Yes.
Okay, so it's just a quick comment that both in this measurement and my measurement, I forgot to say that we are evaluating static run, meaning that we don't look into the runtime run. So just as an addition to both presentations.
Yeah, thank you. Thank you for the comments.
Thank you. Thank you for the clarification, Osama.
Yeah, thank you, Osama T. Dresden. I just wanted a clarification on slide 8. When you say message by referencing, so does it mean that you do not actually transmit the evidence, complete evidence? You just somehow send some pointer that there is some reference pointer as a reference to that evidence. So
So
what does that mean?
You mean what I said during the evaluation results slide?
So slide 8, yes, this one.
Okay.
So the graphs that you are showing on the credential transport by reference.
Okay.
I just want to clarify what reference means.
Oh, okay, so actually this is nothing to do with the evidence, because as you see the green part here is for the evidence. So what I mean here is for ad hoc process, because ad hoc can support either transporting the credential by value or by reference. So actually here is mean that I'm transporting the credential for the authentication by reference. It's nothing to do with the attestation.
Okay, so it's nothing to do with the attestation evidence or attestation results.
No,
So
it's for the
something with the ad
authentication.
hoc protocol itself.
No, it's like it's only for the authentication. It's not for
Okay, okay,
attestation.
right. And one more question about the slide 9, the next one, which is, so you are saying that basically the most of the delay comes from the signatures. Is this correct? So that the signing, which is for the evidence, or is it some part of ad hoc? So I just want to clarify.
Oh, okay, because our evidence is an attestation token, and this
Yeah.
token is signed. So
Yeah.
what I mean is that we need to have a signed attestation token. So this is the
So this is signature of that attestation token and not
Yes.
the signature of your ad hoc protocol itself, right?
yeah, yeah.
Okay, okay. Thank you very much.
Thank you.
Thank you, Weiban. I have a question about the trust assumption between the IoT devices and the network service and the verifier. Do you assume there will be only one verifier? Because which verifier should be trusted by the IoT device or the network service? And for example, if you in the network service attestation, do you need to, do the IoT device need to tell the network service that you need to contact which verifier that I trust, or such kind of information should be conveyed from the IoT device to the network service, and in the background check model, you do it in the opposite way. Yeah.
Okay, yeah. So first, okay. So first question, if there's one verifier or more. So actually, right now we only have one verifier because we are doing a single point-to-point attestation. So now we have only one verifier, and then for the, you mean like, should the attester indicate which verifier can it to evaluate the evidence. Now we don't specify this in the draft because we think it's the relying party who needs to find this verifier, because it's the relying party who consumes the attestation result from the verifier. So like there's it's the relying party who needs to trust the result from that verifier.
Yeah, but for the attester, from the perspective of a tester, it can contact any verifier, but he doesn't know which verifier is trusted by the relying party.
Actually, in our model, in background check model, the attester is not contacting with the verifier. It's only the
Passport model, for
Okay.
example.
Okay, so for passport model, yes, that's why we have the result proposal and result request. So this two EAD items is to find which verifier it can be trusted to get the attestation result.
So you mean you contain such information in
Yes.
the EAD?
Yeah, it's in EAD
okay.
1 and 2.
Okay. But I see in your pages, you say that the EAD value is empty.
That's for the trigger, like
Okay.
to signal the start of the
Okay, thank you.
Okay, so we'll take one more last question.
Thank you. This is Yogesh from ARM. Two questions I have. What made you select COSWID to be wrapped inside EAT? Because COSWID is more like for file systems and stuff, but you are working on a constrained kind of use case. So that is first question. And maybe I will ask the second question after I hear your first answer.
Okay.
So
Yeah, okay. So
So if we can be brief, that'd be good.
okay.
Both with the answer and the second question.
Okay, maybe a brief answer is that we are following the draft entity attestation token. That's also a draft in IETF. And in that draft, they have specified that for the measurements claim, you can use COSWID. So we are following their definition. Yeah, and it's also more lightweight than PSA. So that's why we choose COSWID. Yeah.
okay, we'll discuss offline on that.
Mhm.
Second question, are you following, how does your verifier know about the reference values and endorsements? About that, you haven't mentioned that, but we can discuss that if
Yeah.
we are running out of time. And
Yes.
the attestation result format.
Okay.
So let's take that discussion offline, I propose. I would like to start a show of hands of how many people have read this draft.
So
Yes.
and again, I posted in the chat. If you're remote, just send a +1 or something. Okay.
Okay.
That's 6. No remote support. So about 6 people. Okay, thanks.
Okay.
Yeah, great. So we'll I think at the end we'll think about calls for adoption, whatnot, and so that's
yeah.
the number of people who have read things will factor into that, I guess.
Okay.
Great.
Okay.
And you're on.
And there is your on +1.
So
Okay.
that's 7. Great.
Okay. So the next,
Thank you.
thank you, Sean. The next item on the agenda is Greece by Christian. So yeah.
Can you pass me slide control? Then I can browse.
Mhm.
Or whatever works.
I think it's happening. It's happening. Well, maybe it's happening. Maybe it's not.
Yeah, I need to
One
stop.
second.
Try now.
Well, you have to they need to be up.
They need to be up. Greece revision 00.
Yeah, but I can. Okay.
So you, yeah.
So you haven't them. Okay.
Yeah.
Okay. So hello. I'd like to talk briefly today again about Greece, which is short for generating random extensions and sustaining extensibility, and applying that to ad hoc. Brief moment to rethink back to London a few years ago. We were warned that we have to be very careful in ad hoc to not just become TLS again over time. So I think we shall heed that warning and be selective about what we pick from things that were done in TLS. But I think that's a good one. So I think that and there has been a lot of text written about that already in other drafts. Concretely, there is not only Greece for ad hoc, which defines those options, but also general guidance in RFC 9170 and an upcoming draft on how to do this, how to use extension points, even if they are not used actively, in such a way that it is made sure that at a later point when we want to rely on them, they are still usable and not broken by software that has ossified on the absence of them or on particular usage patterns that are like the only thing that is supported. And that's what I'm doing in this draft. Concretely, I think we should have a few extension point, a few EAD items registered and a few cipher suites registered. None of them actually do anything, but people are encouraged to like sprinkle them over their connections when they know that it is suitable in this concrete case. That means it is not exceeding the message sizes that ad hoc is so carefully trying to uphold, so that any errors that result from broken implementations, from middle boxes, from other kinds of ossification show up early and do not kind of silently corrupt the extension points. There are two extension points that I don't register anything for because they are not negotiated. So if we start using them, like things break because you can't continue on them by the protocol design. We can certainly talk about whether that makes sense to do something there, but I've explored a few options and I don't think that this should be in a small draft, which this still aims to be. So yep, I've gone through a few iterations of this. I've worked in input from various parties, including the RFC shown a few pages earlier. I don't think this will get any better as an individual draft. And that's all I have to say on that, because everything else I think is with the working group in the chat. Thank you. Questions?
Thank you, Christian. Do we have any questions?
Well, in
So,
that case, we're saving time. So.
yes, we're saving time,
Ask
but
away.
let's see how. So the same question goes for Christian's Greece draft. How many people have read this draft? Can I see some show of hands? So
you're on.
So Joran is commenting that he has read it and I think he thinks it's well written and ready for adoption. And I see Marco. And okay. So okay, so we'll be deciding essentially. So there is John as well. Okay, so we are seeing some support. So that's 3.
Okay, so
Okay.
again, we'll think about the adoption things at the beginning.
Okay, thank you.
Next up is
So
PSK.
yes, the next item on the agenda is the PSK draft. So Elsa, so you have 10 minutes, I believe. So you can use.
Okay. So I will present the updates that were made for. Sorry. What? No. Okay. Uh, I'll present the updates that were made to the draft of pre-shared key authentication in ad hoc. I'll be brief because there haven't been many improvements since the interim meeting that happened less than 2 months ago. So basically, I'll present what's the current status of the draft and the PSK variant that was selected to move forward with. And I will also present some of the preliminary results that we have from the evaluation that we are doing with CryptoCell 310. And one of the additions that we made that was talked about during the interim meeting was the need for this fourth message in the PSK2 variant in order to have mutual authentication. So, well, this is the message flow of PSK authentication for ad hoc, so the variant that was selected. The main difference with respect to the other one is that the ID cred PSK is sent encrypted in message 3, which is now composed of 2 concatenated ciphertexts. Also in MAC2, we remove, in message 2, we remove MAC2 with respect to the current status of ad hoc in the stat authentication method. We use the ID cred PSK in the external AAD of the authenticated encryption with additional data. And then message 4, it has the same structure, but it's now mandatory in order to have mutual authentication. This is the key schedule, which has not changed since the previous meeting. And as for the metrics and the evaluation, note here that, as I mentioned, we are doing the experiments with CryptoCell, and we're using the embassy framework as well. So some of the metrics we measured are, first of all, the message size. So here I'm comparing with the PSK variant 1, which was discarded. So yeah, in total, PSK variant 2 has 97 bytes, in contrast with the 93 of PSK 1. We see that there's like 1 extra byte in PSK 1 that comes from the ID cred PSK that was sent in the clear in first message. Then the 9 bytes that we have in message 2 extra in PSK 1 come from this MAC2 that was kept in the PSK 1. Then message 3, we have these 5 extra bytes that come from the concatenation of the 2 ciphertexts, and then the 9 bytes from the message 4, which is mandatory in PSK2. As for the number of operations, both of them had the same number of operations. This was already mentioned in the previous draft. So we have 2 asymmetric operations and 4 symmetric operations, so that is the same for both. Then regarding handshake duration and energy consumption, PSK variant, the second variant, which is the one that we're keeping, is slightly faster for the initiator side, compared to PSK1 and the stat method. Energy consumption is similar, so the current consumption, it's in average, it's more or less similar for all of the variants. And then as for memory consumption, we measured the flash memory, and this was done by filtering the map files after compiling the code. So we have that PSK 2 has slightly higher flash memory, and this is because there's more code needed for these versions. So this is coherent. It's what we expected. And then as for the stack usage, this was measured using memory painting, and it's similar for all authentication methods, which is like around 30 kilobytes of memory. And well, these are the graphs that show the energy and memory. Sorry, energy and time duration of PSK2 and PSK1. And yes, as for next steps, maybe we could think about integrating in the current Lakers implementation and maybe call for adoption in the working group. And that's
So let's first take any questions. Are there any questions on Elsa's presentation? I hear none. So thank you, Elsa, for the presentation. Can we see a show of hands of who has read this draft? So there is. So please raise your hands so we can see it.
Okay, that's more hands up. Okay.
Okay.
You have 3 in the room. Any remote people have read this? or-
So anyone remotely?
Okay.
So that's 3. Okay. Thank you. So as author, yes, Joran is commenting that as author he has read it. Okay.
That's consoling to hear. Okay. Great. So yeah, I think at the end we'll come back to the call for adoptions kind of thing. 'cause,
Yes.
yeah,
Yeah,
there's
we'll
a
come
bunch of
back to
them.
that. So there is 4 drafts, I believe, that are asking for call for adoption. There is Francisco. So we have. So this is number 4 people. Around, yeah. So around 5.
Marco again. Profiles.
So thank you, Elsa. It's great to see that progressing. Let's go with the next item on the agenda, which is Marco's app profiles draft. So give me a second. Coordinating the use. Okay, there you go, Marco.
Thanks. Hello again. This is an individual submission of me and Rickard. I'm version 3 on coordinating on the definition, distribution, and use of ad hoc application profiles. Why we wanted to do that? The 2 ad hoc peers have somehow to agree and get on the same page of a number of parameters. A few are negotiable during ad hoc execution, but a bunch of things have to be known quite in advance. And that's about the concept intentionally openness understand introduced in the ad hoc RFC of ad hoc application profile as a collection of parameters and ways to run ad hoc between the 2 peers. And one of the sub problems remained open was how to simplify, facilitate the processing of defining and distributing, fetching, whatever, these application profiles and their description. Honestly, this point started once again in that core document, and then was decided on something more general, possibly for Lake, and it ended up as part of the scope in the revised and current charter of the working group. Okay, to go through the updates since version 1, actually, it has been a while. Now the table of contents should be much better organized and clearer to follow from an editorial and the logical point of view. And we made quite some effort to keep this up to speed and align with the developments, again, of the ad hoc underscore profile base that somehow comes back here again for the sake of reusing parameters, concepts, and namespaces, and also minor revisions to IANA considerations. What you see in the bottom half of the slide is basically the table of content covering the different contributions in the current order and what has changed most recently. The first thing, and it really started with that, was the idea to identify an application profile by integer, with these integer identifiers in turn registered in a newly defined IANA registry. That part got updated, and then we defined new parameters that contribute to, if present, of course, to the possible description of an ad hoc application profile based on concepts that were never nailed down as parameters, but already the ad hoc RFC introduced. We haven't touched actually the CBOR-based canonical proposed representation of a NetDoc application profile as a CBOR map in the interest, for example, of distribution, installation, and configuration, but we are quoting some contribution we got on its concept. And we have finally written down the description using that CBOR-based canonical representation and the early registration of a first set of proposed well-known profiles. Checking this a bit more in detail on the identification part, that again is the first one and based on integer identifiers. As a recap, we identified two venues where this can practically happen. One is a web link in terms of a target attribute with value, the integer identifier of the application profile in question, or as a parameter of an ad hoc information object, which is basically a CBOR map that is defined and is used in particular, again, in the ad hoc underscore profile base. The update we made in this respect applicable to both venues is defining a hybrid behavior that was discussed and agreed last time this was discussed. The two extremes that were possible already were either you provide in a web link or in a data structure only the integer identifier of the profile and that's it. Or instead, you go for listing the parameters and information that compose them. We are admitting a middle ground, which is the identifier plus only one possible thing more, a set of identifiers of EID items that are supported in addition to those possibly intrinsically supported by the profile. And that's to prevent a possible explosion of registrations of profiles that are very similar but differ only in terms of EID items that they support. On the additional parameters that describe aspects of the application profile that, again, ad hoc mentioned already, en passant as text, we could find this 4 pieces of information for which now we have corresponding parameters that, again, can practically become target attributes in a web link or parameters in a data structure like that CBOR map. And it's in order to indicate the maximum intended site of an ad hoc message, the presence or not of the content format option, if we are talking specifically about ad hoc over co-op, the type of identifier of an endpoint, which turned out into defining a new registry right now with one only proposed early entry, EY64, that the ad hoc RFC also considers. And finally, the identifier of the transport that is supposed to be used for running ad hoc, and we are pre-populating a new registry, again, with 3 possible alternatives related to co-op and its underneath possible transports. Not yet. Oops. Could you change slide?
No, okay.
This stopped working. Thanks. Yeah, on the CBOR-based canonical representation, as I said, we have changed this. It's still a CBOR map that is supposed to provide a canonical way to define a profile and circulate it with a few entries that must be there, a few that must not be there because they don't make sense in this context, and then anything else optional. It's reusing and recycling the same parameters and namespace that we defined in the first place for the ad hoc underscore profile base. So in a sense, we should avoid confusion here. What I wanted to mention regarding this topic is that we extended the introduction with some text defining better the motivations that support the use of something like that. And this largely based from input that we got on the mailing list from Brian earlier this year. So thanks again for that. The introduction hopefully captures that well. On the first proposed set of well-known application profiles, I showed them in a previous presentation as a rough sketch. Now they are properly written down using the CBOR-based canonical representation again, but that's just for the sake of presenting them in a canonical way, and then we use them as initial entries for this new dedicated registry. And of course, they're totally arbitrary. We may want to remove some, tweak some, add some. That's totally open for more discussion. But this is basically the registry as it looks like pre-filled now, and I've highlighted in the bottom left of the slide the 2 extremes of the spectrum. So as I could imagine, as the minimal and the super advanced profile supporting what is the second trace in RFC 9529 basically, and what is pretty much everything essentially. and they are just well known. They are supposed to reflect what is most used or desired to be used. By no means are they intended to be a de facto default or bypassing what is supposed to be mandatory to implement. Absolutely not. Okay, as next steps, there has been some discussion among co-authors and other colleagues about defining yet another venue when the same sort of information can be exchanged, and that's ad hoc itself in a new ID item for the first 2 ad hoc messages, or in case that exchange fails immediately, basically. Also, the ad hoc error message used as reply to ad hoc message 1. And it'll be about reusing, again, the same parameters and namespaces that we have been using for the other 2 already used venues. And we got also a comment from Ayana to address. So right now for this document, we are not in the situation where we can really say, we've said everything we wanted to say. There is something more to say, like listed in this slide, but we got quite good feedback and input on the way forward at the hackathon, also encouraging to accelerate in a sense. I read it that way. So unless the working group really wants to see those things written down in a version, I believe this may be considered for working group adoption too. Okay. Thank you.
Thank you, Marco. So we hear Christian in the queue.
Hello, Christian. I think that this EAD items are very, very important because they enable us to use ad hoc in situations where we can send KIDs by default and not send by value all the time. So we need something like this, and I don't care whether it's in the document or not before we start progressing this.
Thank you. Any other comments or questions? No. So let's do a show of hands of how many people have read this draft. Anyone who has read this draft, please raise your hand. So that's 2. And people who are being remote also. This question applies to you as author. Okay. Okay, so we acknowledge the importance of the draft and that it resolves. My understanding is that it resolves the use case that is going to be discussed in the following slot that we discussed during the hackathon. Okay, so that's two people who have read it. Thank you.
Thank you.
Thank you. So before we go next, so do we have Marek in the room? No, so he seems okay. So my understanding is that TA hints. Okay, so there is Joran. Yes, Joran.
Yes, okay, you're going to TI hints. That was what I was going to say. I'm also co-author. I have not any slides and I have not prepared anything, but I can just say a few words if you want, since Marek seems to be.
Yes, please.
Okay, so we submitted this draft, the TA hints drafts version 0.0, and then Marek prepared something, and he was called into a meeting by his manager. So and that was supposed to end like 45 minutes ago, which we might not have done. I don't know. So we actually, yeah, here we are. And so let me tell you a little bit about TA hints. The basic use case were addressing things that Marek had experienced in his deployment of ad hoc in ASA Abloy using controlling locks. And they have very strict requirements on time, how fast you could run the protocol, and a lot of time could be spent by unnecessary round trips because there are mismatch between credentials that you have and credentials that you need. So one thing that we were working on in this was to propose a solution for adding hints to what trust anchors exist and what credential types are supported. And we defined EAD items for this and tried to make this in a very nice CDDL And then we had a discussion at the hackathon, and Christian pointed out that the application profile that Rickard and Marco have been the previous presentation actually supports exactly this information about credential types. So we don't need to define this at all, and you can just simply use it and as soon as that becomes an EAD item, we can pass it and then share that information. It didn't support the trust hints, but that's just yet another parameter in the ad hoc information. So that case was also covered. I should also say that this was partly dealing with credentials that are used for authentication in ad hoc, but it's also flexible to support other type of trust anchors. So if you have a security service which could deal with time synchronization, or I mean that you want to have an authenticated time synchronization, or if you want to do the trust anchor, so the verifier for remote attestation, that could also fit into the same purpose and with different purposes, fit into the same type of protocol. But those could also fit very nicely into the the application profile draft that Marco just presented. So basically, what you have obsoleted we think we have obsoleted the need for this draft which we submitted. I see Karsten is in line, so maybe he has a question. I can continue a little bit later. Go on.
Yes, I just wanted to point out that putting something in a registry doesn't save you from the need to actually specify it. We probably need to think about where these documents are going to live. So when we have a specification required registry, of course, somebody who wants to use this registry has to find the documents. And definitely putting something into an IETF document is a good way to store this required specification. But we really have to think about that. Just don't forget it.
Okay, Karsten, are you saying we should describe the use case somewhere? So and how we used the registry sort of for that purpose, or what are you missing if we just delete our draft or stop updating our draft and start working on the profile, application profile?
If you put the information into a registry, then this registry has to either contain the complete information or point to a specification.
Okay, so would you rather say that we have this specification, we describe the use case, that this TA hint /0, that this TA hints draft, we describe it, and then we basically reference this is how you can use the application profile to get this information across. Would that be a that would be okay? Yes. Okay, thanks for your input. We consider that. Thank you. Okay, well, I think I'm actually done with the draft now. Okay, so you want to do? Stephen wants to do something else. I'm happy. I just there was also another thing that Mark wanted to talk about, which was adhoc.me, this new interop service that he is working on, which we had a very nice demonstration of. But I won't be able to take that, and there might not be time for it anyway. So unless someone else would have time to recap that I think that would be, it's a good information item if we have time at the end, all other business or something like that. But I wouldn't be the best person to do it. Thanks.
Okay, thanks, Sharon. And I guess if Mark shows up for the last few minutes, we can use those. So we had 4 drafts. You can see those drafts listed here, plus the TA hint one, which we just briefly mentioned. They have not huge readership. We're not talking about the New York Times, but that's okay. So I guess we're wondering what way would people like to go about us issuing calls for adoption for these, because the authors have asked that we do that. So I guess just want to open it up and see if people have opinions. Are there any logical orderings that make sense? Or should we just randomly do them? Doing 4 at once between now and the end of the year is probably, might just get it in by the end of the year. But if we do 4 all in one go, people might not read any of them. If we can stagger them out, people are more likely to actually read them. So any opinions, or are you just happy for the chairs to randomly toss some coins and decide what to do? So if you have any opinions on which of these 4 drafts we discussed should come before any other ones, which not, you don't care. Does the version number play a role? Marco asked. Meh. Not given the numbers of readers we've had, probably not significantly. I mean, I think the factors here, maybe the Greece thing kind of stands alone. There may be more relations between other ones or other dependencies on other ones. So which would you like to see us issue calls for adoption for first, if any? And it's okay for authors to kind of say, take ours first. If there's an argument, that's fine.
I think Greece is easy.
Please go to the mic and yeah, if you have a chance to hit the button first, great. But we have a few minutes for this. We don't want to take too long.
I think Greece is easy compared to everything else.
It certainly is more standalone, that's for sure. Yeah, and it's probably short. I see a few people nodding on that one. So I mean, I would have thought that too, that we could chunk that one out and sort of start a call for adoption and do that one first and get it out of the way in a couple of weeks, I expect. Any other comments about what should be first, last?
So yes, we have a comment from Joran on PSK.
Karsten's coming to the mic, great. Yes. And again, if you're remote, please just join the queue, type your comment, and it'll all be good. Karsten.
Yeah, just wanted to point out that container mechanisms like this application profile stuff, of course, give rights to additional developments. So we want to have this first, so these additional developments can happen.
Okay, so it's likely that more things would depend on the profiles draft than on others, so therefore do that earlier. That's an argument.
Renzo?
Renzo. Yes, I read both PSK and the one based on rats, and I agreed we should try go first with the less conflicting ones. Sorry, I didn't read Greece, but I can agree that PSK seems one relatively simple. Rats, it's a little bit bigger, and I think still need more work. But I will go like Goran say remotely. PSK, I'm +1.
So yeah, thank you, Renzo. So my 2 cents would be that we should also consider the timeline for the different drafts and apparently the complexity. So the PSK draft will need to see some formal analysis for sure before it is pushed out of the working group. So which already, based on our experience with ad hoc, means 6 months freeze of the specification, at least. So, and attracting those formal reviews would be hard without the draft being adopted. So I think that is another argument for having that one in. Other application profiles and remote attestation, I do not believe we will need formal analysis on. Yes. So it's easy, but it's just thinking out loud about the different timelines and yes.
Okay, so just as a question about the PSK draft, if the working group adopted it, obviously things can be changed. But if the working group adopted it now, do people feel that it's likely to change significantly very quickly, or be something that could be frozen for 6 months soon after adoption? Do we have opinions on that? Please go to the microphone if you have information on that. We don't know. Okay. So we'll confirm on the list, but it sounds a bit like doing the Greece one first, maybe then the profiles, PSK, rats, in that order. If we start now and we kind of give them 2 weeks each, we might get them all done before the end of the year.
Yes.
Anybody, any opinions about doing any of them in parallel versus not? Oh, John, yes. So John says we don't need to prioritize. So my argument for prioritizing is we haven't got many people reading these things. If we do 4 calls for adoption in parallel, nobody will read anything.
Okay.
Yeah, I mean, they don't have to be strictly sequential, but we can. Yeah, let's not start them all at once.
Okay.
I know, yes. Well, they won't arrive at the end of one side.
So, okay, I think prioritization is a good idea, but I guess the timeline is then very clear from here to the end of the year that we call these drafts out.
Yeah.
So, yeah.
And again, if we start the Greece draft and say there's a 2-week call for adoption, if we get a bunch of people saying, yeah, that looks good in the first week, we can start the second one a week later. I mean, that's, if something is uncontroversial and good, we can move a bit quicker. If people say they've read it and like it. So reading is the key here. Okay, did Marek turn up in the chat or in the room?
No, I still don't see Marek. So perhaps I can say a few words, but about the discussion at the hackathon about what Marek has presented. So Marek has presented us with his plans on building an interoperability on interoperability on server that we could use for interoperability testing, based on a low code programming language called Node-RED that is based on JavaScript. So this is a visual kind of programming language that where you can drag and drop different blocks and build your flows. Typically, it's used for IoT, Internet of Things teaching, and also some deployments. We are at INRIA, we are extensively using this for teaching. And now this Marek's plans come very well aligned with ours on the use of this tool, and his plan is essentially to push this out before the end of the year, such that it becomes available for everyone to just use import ad hoc, for example, and build different flows using co-op, UDP, but also other transport technologies to transport ad hoc. So that would be kind of a sum up of what Marek was going to present and what he presented to us at the hackathon. But we will, as chairs, take an action item to ask Marek to present this at the following IETF meeting if this becomes live indeed in this time frame. So with that, we have 4 minutes left for any other business. I
assume we don't need an interim before the end of the year.
Do we want an interim before the end of the year? Do people have opinion on that? Because the next IETF meeting is in Bangkok in March. So the question is whether and when we want an interim meeting. So we have many drafts in the pipe now. So meeting before Bangkok would indeed make sense to me, at least. But when I see people nodding, so without further input, I'm tempted to say after New Year's, so essentially sometime in January. So we are kind of midway between now and Bangkok, and we discuss the progress of the working group items and the adoption of new drafts. So a generic interim meeting on that. Is there any objection to that? Yes, virtual interim. Virtual interim. Yes. I kind of assumed that.
Well, you can come over. You can come back here if you want, and we can stay in the room.
We like it so much, Steven. So yes. I hear no objections. So the chairs will take an action item to schedule an interim meeting in January after the vacation periods. With that, I would like to thank everyone for the meeting today and see you online. Thank you.
Thanks so. Thanks to our note takers as well, especially.
Yes.
So if we kick off the Greece one.
This one is easy. Yeah.
We kick it off next week and say like 2 weeks. If nobody answers, then we can say, okay, we're going to wait 2 weeks. Then the next one. If a bunch of people say, oh yeah, that looks good.
Yeah, it's been around.
So then we'll go start the second one a week later.
But I would give it more time between them. I don't expect a whole lot of feedback.
Yeah, but we're good. Like if we get like 10 people saying, yeah, that's good, looks good.
Yeah.
That's probably as much we're going to get.
Yeah.
And that's okay. So then we could start the second one once we're happy that it looks like a yes.
I just want to get the PSK out for formal analysis purposes as soon as possible, because we will want to repeat the exercise of freezing the thing and then announcing like to the researchers.
Yeah.
So this, but if it happens by the end of the year, I think that we're fine. So as soon, so
Yeah. Yeah.
so we should get it, because I'm thinking aloud. So we adopt that by end of the year. So it's a 0, 0 in January.